Morning guys, welcome to this, our Easter paper 2 course. So on Wednesday we took a quick run through paper 1, had a look at a lot of the important questions for paper 1, the things that are most likely to make an appearance this year. Obviously what we're going to do this morning is we're going to do something similar for paper 2. Okay, so I'm going to take a look with you at the most important stuff on paper 2. You might let me know in the chat if you can hear me okay. As I said, make sure you've downloaded your notes from the download notes tab on the main page. So what we're going to take a look at today, and there's kind of 3 important topics I want to have a look at because a lot of you have been asking about these topics through the type form over the last couple of weeks. So I want to have a quick look at some of the trigonometry, and I'm going to have a quick look at some probability and the line and circle. I don't propose this morning to do a great deal on statistics because we did cover statistics in a masterclass relatively recently, and the statistics masterclass is up on the platform for you. So if statistics is something you're struggling a bit with, you can find the masterclass on the platform and have a look at that. Okay? So what I'm going to have a look at here is I'm going to have a look at trigonometry, probability, and the line and circle. We're going to prioritize this morning. All right? So what we're going to start off with then, if you look at the notes, so we're going to begin here looking at a little bit of the trigonometry. So I'm going to look at the trigonometric functions for sure, because I think we might get a long question on trig functions this year on paper 2. All right. We'll have a quick look then at the equations and proofs, and I'll just do 1 or 2 of the questions on diagram-based trigonometry, just showing you some long questions there using sine rule, cosine rule to solve triangles. All right. I'll then have a quick look at some of the probability. There's kind of a sample question for a lot of the probability there, and then we'll take a quick look at the line and circle. Okay, so as I'm not going to do very much statistics this morning, and we've kind of covered that already relatively recently. And the geometry, I will be doing a masterclass on geometry just after Easter. A lot of you have asked about that, so I'll do a masterclass on geometry just after Easter and maybe have a chat through that. Okay? Thanks, Eddie. Right, so we get stuck in then straight away. So the first question I'm going to have a look at then is the one on page 5. Okay, so we have a look at the question on page 5. Just bring that one up. Okay. So here we go. So this is a long question on trig functions, right? And if we read the question there, it says, Atif has breakfast at 7 a.m. His blood sugar concentration, C of T, measured in, there's the units, milligrams per 100 centimeters cubed of blood, over the next 5 hours, can be modeled approximately by the following trigonometric function. C of t is 98 minus 21 times cosine 4 pi over 5t. Notice we're told that the 4 pi over 5t is in radians, all right? And where t is the time since breakfast measured in hours. Okay, so we've pulled out the important information there. So what the formula is telling you there is that C of t, blood sugar concentration, is given by 98 minus 21 times cosine 4 pi over 5t, right? And we're told that this is measured in radians. Now, the reason that's in radians is important, okay? Because when you get a long question on trig functions like this, whichever paper it's on, paper 1 or paper 2, he will usually bring in calculus. Like we met back on Wednesday when we were doing the logarithmic function, if he uses the word rate, he wants you to find the derivative. And as we'll see now in a moment, if he talks about an average value, he wants to do integration. He wants you to find the integral. And the shortcuts for doing differentiation and integration on page 25 and 26 of your formula booklet only apply when angles are measured in radians. So if the angles were measured in degrees, the formulas in your formula booklet would have to be tweaked to allow for that, and that's not in the Leaving Cert course. So if you're going to be asked to do any differentiation or integration, which will very often be the case, you're going to have the formula in radians, so that's why they're in radian mode. So when I see the word radians there in the phrase in the question, I would straight away, so I don't forget, switch my calculator into radian mode. So I'll be operating in radians for this question, right? Now, if you get one of these, remember there was one of these as part of question 8 on paper 1 last year. So there was a trig function on paper 1 last year as part of question 8, which means I think it's more likely it's going to make an appearance on paper 2. I'd be very, very surprised if it's not on the paper somewhere. All right? But I think it's a bit more likely to make an appearance on paper 2. That's what the trend has been over the last kind of 7 or 8 years. It's on the paper pretty much every year, and he just switches between the 2 papers. Okay? But the maths will be the same, right? So whichever paper it appears on, the first thing I would do is I would sketch it. Okay, so when you get a graph of this, start off by doing a rough sketch. In the box there for the answer, not in the margin, make sure it's where the examiner can see it. Because you're very often going to find you're answering questions here without even realizing it. Right? So the first thing to look at is the basic shape. So it's a cosine function with a negative number in front. So that's a minus cosine function. So just remember, you do need to know those 4 basic shapes. Okay, so make sure you're familiar with the 4 basic shapes of a trig function. Remember that these trig functions are all periodic. The same basic shape repeats itself at regular intervals, right? And that's the basic shape that repeats itself at regular intervals for each of the 4 kinds of graph you'll be dealing with in a real-world application. You won't see any real-world applications of the tan function because remember, it's discontinuous. Okay, so it doesn't really model anything that happens in the real world, right? So that's the basic shape of a sine function. It starts on its center line, goes up in an N, down in a U, and then repeats that infinitely in both directions. And putting a negative number in front, making it a minus sine graph, just turns the graph upside down, or gets the mirror image in the center line more accurately, right? So you can see the mirror image of that N is a U here, the mirror image of that U is an N. So it literally just spins the graph around its center line. So that's a positive and negative sine graph. And remember, a cosine graph starts at its highest point, comes down to its lowest and back up to its highest point again, okay, and then repeats that basic shape infinitely in both directions. And again, putting a negative number in front flips that one upside down, okay, or gets the mirror image of that one in its center line. So the 4 basic shapes, make sure you've got those, okay, that you're familiar with the 4 basic shapes. And because this time we've got a negative cosine graph with a negative number in front, that's our basic shape. So that's the basic shape. Make sure you know those 4 basic shapes, right? So for this one here, the basic shape will look something like this. There's my center line running through the middle like that. Start up here, come down like that. That's the basic shape, okay? So we start off with the basic shape of the graph. Now, the 3 numbers, make sure you know these. This is really all you need for trig functions, these 3 numbers here. The number by itself, the constant. Okay, what I mean by the constant is the number that's not attached to the word cosine. So anyway, these numbers are attached to the word cosine. That's not. So that's the number by itself. It can be at the beginning or at the end. But it's the number that's not attached to the word sine or cosine. That's the constant, and that's always your center line. Okay, so remember, so that's the center line of my graph here, the line that runs through the middle. So the number by itself, the constant, is your center line, right? Secondly then, the number that's in front of the word cosine or sine. Okay, that number there, all right, the 21, that's the amplitude. That's how far above and below the center line your graph's going to go. So it's going to go up by 21 and down by 21, right? So if we go up by 21, we'll add 21 here, and that'll bring us up as high as 119, right? And if we subtract 21 here, it'll bring us down as low as 77. So that number there is the amplitude. It's how far up and how far down, above and below the center line your graph will go. And that will allow you to work out what the highest and lowest points in the graph are. So even just notice here, without doing any further heavy lifting, look at part 1 of the question that we're trying to answer first. It says, what will Atif's maximum blood sugar over the next 5 hours be? Job done for 10 marks. All I've got to do is put in the units. Okay, so I'm actually answering part 1 of the question just by doing my sketch here, right? And then finally, the last number here, that number, the number in front of the letter, T in this case, that will tell you what the period of the graph is. So how long it takes before that graph starts repeating itself. All right? So to find the period of any graph here, you take a full circle and divide by the number in front of this letter here. So I'll divide by that number there. Remember, a full circle, because we're in radians, the whole question in radians here, a full circle is 2 pi. Okay? So if I take a full circle, which is 2 pi, okay, and divide that by the number for the t here, divide that by 4 pi over 5 on my calculator, I get 2.5, right? So that's the period. So once after 2.5 units along the x-axis, the graph's going to start repeating itself. That's the idea here. Okay, so they're the measurements I want. So now I've kind of sketched out the graph, and I've got a pretty good idea what's going on here. And what I might even observe here is that's the halfway point there. So halfway between 0 and 2.5, that's 1.25. Okay, I'll show you why I'm noting that now in a second, right? So see that before I even start answering any parts of the question here, all right, I have a pretty good idea what happens with this guy's blood sugar. It starts off, sorry, it's a minus cosine graph, sorry. Doesn't change anything, but just it won't change any of the numbers. Okay, minus cosine graph. Okay, like that. So it's a negative cosine graph. Okay, this wrong shape. Okay, but that's the basic repeating shape there. All right, so that's what my graph looks like. So his blood sugar starts off at 77, goes up to a high of 119 after an hour and a quarter, and then comes back down to 77 again after 2.5 hours, and then just keeps repeating that basic pattern. Okay, so that's what this graph looks like. So if I sketch that first, you'll be surprised in an exam how often you're actually answering parts of the question by doing that. Okay, so that's the graph sketch there, right? So now, part one then. Part one says, what will Atif's maximum blood sugar over the next 5 hours be? Well, I can just write that down now. I've done the sketch. That's my calculation done. So it's 119. And what are the units? It's milligrams per 100 centimeters cubed. So they're the units given the question. You'll lose a mark if you leave out the units. Is that okay? I said, if you have any questions now, fire them into the chat. I'll answer them as we go along. Okay, but that's his maximum blood sugar. But I would always advise sketching that graph there before you get started, because it'll tell you a lot of what's going on here. And the examiner can even give you marks. So if you'd sketched the graph here, but hadn't actually answered part one, he'll give you 4 out of 5 or 9 out of 10, because you've actually found the number there, you just haven't written it down. The reason he won't give you full marks is because you haven't included the units. It's a 1 mark penalty if I leave out the units. Okay, so try and get the habit of sketching the graph first, because it'll answer a lot of the questions for you. And then part two, what will Atif's blood sugar be at 8:45 a.m.? Okay, so remember, 8:45 a.m. So we're told in the question that T here is the number of hours since breakfast, which was 7 a.m. So the question is, at 8:45 a.m., how many hours is that since breakfast? Well, from 7 till 8, that's 1 hour. And then 8:45, remember, 45 minutes is 3/4 of an hour. Okay, so it's 0.75. So if you take the 45 minutes and divide by 60, that's 0.75, so that's 3/4 of an hour. So that means that T is 1.75, because it's the number of hours since he had his breakfast at 8 a.m. So Keane's asking there, Keane and Jess are both asking there, is there any other way of doing that without using the graph? There is, yes. Okay, if you look at it, there's a buzzword in there that'll tell you how you could have done that without using the graph. Okay, remember, we're trying to find his maximum blood sugar. And that's a buzzword, isn't it? For either paper, that if I see the word maximum, right? Remember, we did that on Wednesday. How do you find a maximum or minimum point? You put the derivative, you can say it's finding a turning point. So that's a turning point there, right? And you would find that by putting the derivative equal to 0. So if you found the derivative, okay, which we're going to do in a moment anyway, put it equal to 0 and solve the equation, right? You would have found the answer you're looking for. So as I'll show you in a moment, if you find the derivative and put it equal to 0 and solve, the number you'll get is 1.25, because that's when the maximum happens, right? And then sub that 1.25 in here, and you'll find the 119, and you'll get full marks. Okay, so Keane and Jess, I hope that answers your question. If you didn't know that buzzword there, maximum, it means put the derivative equal to 0. That's another way of doing it, but the sketch is quicker. Okay, entirely up to you. So if I sub in the 1.75, so seeing what the answer is, 1.75 like that, it's just sub into the formula, 98 minus 21 times cosine 4 pi over 5 by 1.75. And as long as my calculator's in radian mode, I just pop that straight into my calculator, and it comes out at about 104.5. Okay, and again, put your units in, it's milligrams per 100 centimeters cubed. There's no penalty there for rounding. If you round out the nearest whole number, that's up to you. He didn't give you any guidance on how to round it, so he won't penalise that. But you will lose a mark if you don't put the units in, every time. Okay, so that's part 2. Now, part 3 then on page 6. If he asks you a trig function question, which he pretty much always does, all right, he will always include part 3 where you're solving an equation, right? See what it says there? So in part 3 it says, for how long over the first 5 hours will his blood sugar exceed or be bigger than 107 milligrams per 100 centimeters cubed? Okay, so for how long during this 5-hour period will his blood sugar be above 107? So this time, the number given in the question, 107, it's a value for C, it's a concentration value. So it's going to go in, so we're going to put the 107 in the left-hand side here and solve the equation we end up with. Okay? So, what does that look like? So I put the 107 in, I get 107 is equal to 98 minus 21 times cosine 4 pi over 5t, like that. Okay? So if I move the 98 across, first of all, so 107 take away 98 is 9. So obviously just move the 9 over onto the left-hand side. All right, so we get 9 is equal to minus 21 times cosine 4 pi over 5t. Okay, like that. And then divide across by this number here, divide by the minus 21. So we get 9 over minus 21 is equal to cosine 4 pi over 5t. Right, so divide across like that. So, once we get this far now, you can leave it, obviously you can simplify that to minus 3/7 if you want to, but you don't need to. It's going into your calculator now in a second anyway, all right? So to remove the word cosine, I'll go with inverse cosine of both sides, okay? So I go with inverse cosine on the left-hand side, like that. That's going to remove the cosine here, so it's equal to 4 pi over 5t. Okay, and if you pop that into your calculator, if your calculator is in radian mode, the inverse cosine of 9 over minus 21 or minus 3/7, whichever way you've written that, is about 2.014. So that's popping that into my calculator there, and then divide by 4 pi over 5, and you get that t is equal to about 0.8 hours. Okay, so t is about 0.8 hours. Right? Now, I would just push down and find that value anyway, because whatever number of marks are going for this question here, you're going to get the highest partial credit mark for just finding that first value for t. We're actually looking for 2 here. We want 2 values for t because we're trying to find how long it is, or how long his blood sugar levels are above 107. So I'm going to need both and 2 different answers here, because if you remember what your sketch looks like, the sketch looks like this, right? And remember, that's 98 there. And that's 119 up there. So 107 is kind of in between them. So 107 is in here somewhere. So if we go across like that, there's the 2 times during a cycle when his blood sugar is equal to 107, right? And that's what we're looking for. For how long is his blood sugar above 107? So I'm going to need these 2 times here, because it's in between those 2 times his blood sugar is above 107. And because we're looking for 2 answers here, it's very easy to kind of say, well, what I'll do here is when I get to this equation here, I'll use the kind of the cast circle method. You know, when you're solving a trig equation and you want multiple answers, okay, that we do it that way. We use the inverse cosine of both sides here to remove, we use the inverse cosine to find the reference angle, and then use your cast circle to find the 2 solutions. I wouldn't do that here in a real world problem because the numbers get very messy. Right? So what I would just make sure I do is guarantee myself at least the high partial by just getting t by itself. Because actually it's surprisingly easy now to find what the other answer is. Okay, what the second answer is. Because the graph is symmetrical. Right? So what that means is, if you think about this, so this here is that's 0.8 there. Okay, which remember makes sense because we thought a moment ago from our sketch that that's 1.25. So between 0, that makes sense. So what that means is the first time here is 0.8 hours in from the left-hand side. See, so we come in 0.8 from the left-hand side. So because these graphs are symmetrical, the right and left-hand sides are mirror images of one another. So if the first time is 0.8 hours in from the left-hand side, the second one is going to be 0.8 hours in from the right-hand side. Okay, so I'll just use the shape of the graph to find the second time. I'm not going to try and solve a cast equation here. And remember, what's this end of the graph here? Remember, that's 2.5. That's the period we found earlier on. So this end of the graph is 2.5. So the first one is 0 plus 0.8 in from the left. This one is 2.5 minus 0.8. Okay, that's 1.7 hours there. So I think it's a little bit easier rather than trying to use the cast circle to do it that way. So Caroline, the notes, if you go to the download notes tab on the main page and go down near the bottom, it's download the Easter notes, they're in there. Okay, that's where you'll find those, Caroline. And yeah, so John, this diagram here, it's not as easy. So for example, what we were doing back on paper 1, if I'm sketching a graph for an exponential function or a logarithmic one, it doesn't give me as much information to help me answer questions. Okay, so while you can, if you're dealing with other kinds of functions like exponential or logarithmic or cubic, you can by all means sketch them. But I just don't I haven't seen any Leaving Cert questions where sketching the curve gives you any information that makes the question easier to solve. So you can, of course, do it. Remember the one we did back on Wednesday with the log function where the graph looked like that, right? So what it did tell me was the graph was always increasing, so my rate was always positive, but that didn't particularly make solving the question any easier. So you can sketch a graph for any type of functions question, but I think for the trig ones, it's the only ones where it's really an advantage to do so, where you really benefit from doing so. Okay? I hope that answers your question. So Rory, yeah, I will be doing a cast. I'll be doing a cast one now in a second. Yeah, I'll be doing a cast one now in a second. And Sarah said, how would this work if it was a sine graph? I'm going to, the next question has a sine function there. I'll show you that one with the sine function. So question 2 has a sine function there. I'll do the sine function question in a moment. Okay, because yeah, you can see that the sine function looks like this. Okay, so it's this part symmetrical, that part symmetrical. Let me have a look at that. We'll have a look at question 2 in a moment. Right? So that's 1.7 hours. So you can see the difference between these two here. It's in between those 2 time points. It's when it's above. So it's 1.7, take away 0.8, that's 0.9 hours. Okay, so in that particular cycle there, the blood sugar is above 107 for 0.9 hours because it's in between these two, in between the 0.8 hour time mark and the 1.7 hour. You can see that's when the blood sugar is above 107. Okay, so it's for the 0.9 hours that lies in between those two. Now, there's 2 things I got to do to get full marks there. Yes, so Owen, yes, the answer to that question is yes, 100%. That if you use the cast method 100% to get you the right answer, we'll get you full marks. Absolutely, no doubt. Perfectly fine, all right? And the other question that I was asked there by Jake, and really good questions these, all right, and what would happen if I drew the graph wrong? Right, so would I still get the marks? Remember, the key idea in the marking of Leaving Cert Maths is that you don't carry a mistake forward. So if you sketched a graph the wrong way, like for example, what I did when I did it on the board originally when I was a bit careless, I drew the graph upside down. I drew the wrong graph. All right. So what would the result of that be? Well, obviously I'll lose marks for having drawn the graph wrong. So the first part of the question where I've drawn the graph wrong, I'll be penalised for. But if I then use that incorrect graph correctly for the rest of the question, I shouldn't be penalised any further. You don't keep on getting penalised for the same mistake. So if you drew a graph wrong at the very beginning of the question, and you can say, I answered all the rest of my questions based on that, the examiner said, well, if he keeps on penalising, you're being punished over and over again for the same mistake. And that's not how the marking scheme works. So you'll be penalised for the first wrong answer you get for drawing the graph incorrectly, because there's a problem with your method there. But if you continue with that graph and answer the remaining questions correctly with the graph you've drawn, you won't lose any further marks. Okay, that's the idea of not carrying the mistake through. Okay? Okay, so I think that deals with all the questions we're asked there. So it's 0.9 hours. Now, there's 2 things I've got to do to get full marks here because I'm not quite done. First of all, notice what he said is he wants to answer the nearest minute. So just be careful of that. Remember, that's in hours. So turn that into minutes. So 0.9 multiplied by 60 is 54 minutes. Okay, so you have to remember, he wants it in minutes, so you have to turn it into minutes. There'll be a penalty if you don't do that, right? The second thing then, there's a reason why that's not the full mark answer either. Okay, that's not fully correct, and I think a lot of people would miss this and lose 1 mark. It's only a 1 mark penalty, will lose 1 mark. Read the question again. It says, for how long over the first 5 hours will the blood sugar be above 107? So over the first 5 hours, how long would be over the 107? So this curve here, remember, just covers the first 2.5 hours. Then that same shape will be repeated again over the next 2.5 hours to bring me up to 5. Okay, so over the first 5 hours, that basic shape there repeats itself twice because each iteration or each shape takes 2.5 hours to complete. This pattern repeats itself every 2.5 hours. So over the first 5 hours, that pattern will repeat itself twice. So it'll be 54 minutes during the first 2.5 hours and another 54 minutes here. So I have to double that and get 108 minutes. Right? Now, as I said, if you get down as far as that number there, you'll get the high partial. 7 or 8 out of 10. Okay? When you get here. If you kind of do this here, get the 0.9 and don't do these, you'll only be penalised a single mark. Okay, so once you find the second time point like that, you're going to get full marks -1 if you don't complete it from there. So say 7 marks for getting here. It would be 9 marks for finding that guy there. And if you remember these last 2 bits here, turn this into minutes, double it and put the units in, you'll get all 10 marks. Okay? Would you lose marks if you separate hours and minutes? No. That's a good question as well. Michael, that's a nice question. Would I lose marks here if I split this into hours and minutes? Right? So if I gave that as 1 hour 48 minutes, no, 100%. As long as your answer has minutes in there, that's perfectly fine. Okay, so if you give the answer in hours, if you gave the answer there as 1.8 hours, you'll be penalised for that. 1 mark, because it's in the wrong form. All right? But if you wrote that as 1 hour 48 minutes, that's perfectly correct. As long as your answer has minutes in there, you're okay. Okay. Some good questions there on that one, because as I said, it's worth kind of having a look at that, because I think anytime he asks a long question on this, the chances are you will get one of those. Right. So if you look at the next part of the question then, so part 4. Okay, I'll just keep that there for a moment. Okay, so part 4. There's a buzzword there. So part 4, the buzzword rate. Okay, so kind of building up a vocabulary check here. So the word rate, as we mentioned on Wednesday with the log function, rate means derivative. And I would straight away write that down. Okay, I'd let the examiner know that I understand what you want me to do here is find the derivative. So remember, we've got this function here that's, c is equal to 98 minus 21 times cosine 4 pi over 5t. And just to kind of maybe to notice here, that see the way it's written in the question this way, c of t. That's just function notation, it's like f of x. All that means is the value of c, his blood sugar, depends on time. It's a function of time. That t there has no bearing on how you do your calculation. It doesn't mean c multiplied by t, because in algebra that would just be written as ct. So it's just c of t, it's function notation. So when you're doing calculations, it's okay to leave that t out. His blood sugar levels are equal to 98 minus 21 times cosine 4 pi over 5t, right? So it's okay to write it that way. You just write that c of t is like f of x. It's function notation indicating that the value of c depends on the value of t. Is that okay? So it's okay to write it this way. So when I want to find my derivative, I can call it c prime of t, like calling it f prime of x as we did on Wednesday, or I can call it dc dt. Whatever that is by itself on the left-hand side goes above the line, and what's on the right-hand side goes below. We dealt with that on Wednesday when we were doing calculus. So dc dt. Now, in order to do this dc dt here, we talked about this on Wednesday when I did the log function. Okay, so when we went on the paper 1 class on Wednesday, we had a look at a logarithmic function where you were asked to find the rate at which the percentage of tickets sold for a festival was changing at a particular time point. And we said that rate means derivative, and the way we do a differentiation is number, function, bracket. Because the function bracket bit of that is using the chain rule, which is what's going to be required here. The very same thing applies for this one. Okay, we're going to do this the very same way, number, function, bracket. So first of all, notice that 98 is a constant. Okay, so that's a number. So if I asked you to differentiate this, if I told you y was equal to x squared minus 2x plus 1, when you find the derivative there, dy dx, your x squared becomes 2x, your minus 2x becomes minus 2. What happens to plus 1? It vanishes. Right? So when you differentiate a constant, it disappears altogether. And that's what this is. That's a constant, so the 98 disappears. So if there's a constant, the number that gives you your center line here, when you differentiate that, it'll disappear. Right? So the 98's gone. And now we do our number function bracket thing. Right? So there's the number in front of the function. Right? There's the function, the cosine bit. And there's my bracket then, the 4 pi over 5t. And what did we say on Wednesday is the approach here? Number function bracket, the number stays put. Page 25 will tell you what the function turns into, because page 25 is where your shortcuts for differentiation are. And then bracket, you multiply by the derivative of the bracket. So that function bracket bit at the end, that's your chain rule, right? So first of all, the number, the minus 21, that just stays put, like that. Minus 21. Okay, now function, what happens cosine? Well, to work out what happens cosine, we'll go to our formula booklet. Okay, so if we just go to the formula booklet, remember the formula booklet on page 25, that's where our differential calculus shortcuts are. So page 25 down here. Okay, there we go, calculus page, everybody's favorite page of the log tables. Where would we be without page 25? Okay, wouldn't our lives be very dull if we didn't have page 25 rattling around there? So page 25 is where all the derivatives are hiding, right? And we're trying to find what happens cosine, and there it is there. See it? That line there, cosine turns into minus sine. So page 25, we're talking about the function turns into, cosine becomes minus sine. Okay? So according to page 25, the cosine becomes minus sine, that becomes minus sine. 4 pi over 5t. So that's the number done, number stays put. The function cosine becomes minus sine. Page 25 tells me that. That's where my calculus shortcuts are. And now bracket, you multiply by the derivative of the bracket. So what does 4 pi over 5t become? 4 pi over 5. It's just like that, isn't it? Minus 2x becomes minus 2. When the letter is in there by itself in a term, the letter disappears. So 4 pi over 5t just becomes the number 4 pi over 5. And those two bits together, function bracket, that's the chain rule. That's what the chain rule looks like when you use it in a real world application. We dealt with that anyway on Monday. And what I would normally do now is I think I'd multiply these two numbers together to tidy that up. Right? So the minus signs will cancel. Minus by minus gives you plus. And 21 times that on your calculator is 84 pi over 5. Okay, so that's the derivative there. That's how we do a differentiation. So the key thing there, the word rate means find the derivative, and that's how you do it. Number, function, bracket. Number stays put. Page 25 will tell you what the function turns into, because that's where your calculus shortcuts are. Your shortcuts are for finding derivatives, as is labelled on page 25. And then you multiply by the derivative of the bracket, because that's what the chain rule looks like when used in the real world. And see that we've got two formulas here now. That's the original formula there, and that's the derivative. What does that formula tell you? That formula will tell you what his blood sugar is at any moment. What will that one tell you? This will tell you how fast his blood sugar is changing at any moment. And remember what we said back on Wednesday when we were dealing with these. If this is positive, it means the graph's going up. His blood sugar is rising. If this is negative, it means his blood sugar is dropping. Okay, the graph is going down. So in my sketch here, what it looks like to me is, if I put any number between 0 and 1.25 in here, I should get a positive answer, because my sketch shows me that his blood sugar is going up for the first 1.25 hours. So anywhere between 0 and 1.25, the graph is going up. So any number between 0 and 1.25 in there should give me a positive answer. Okay? Between 1.25 and 2.5, the graph is going down. His blood sugar is dropping. So if I put any number between 1.25 and 2.5 in here, I should get a negative answer. If that's not the case, either my sketch is wrong or my derivative is, I'll just go and check that. Okay? So if we got a value to sub in, we do. It says at 11 a.m. Okay, so at 11 a.m. So 11 a.m., remember the time here, t is the number of hours since breakfast at 7 a.m. So 11 a.m. is 4 hours after breakfast. So we got to sub in t equal to 4. So when t is equal to 4, it's because that's 4 hours after breakfast, dc dt, it's 84 pi over 5 times sine 4 pi over 5 multiplied by 4. And again, I'll just pop that into my calculator, and that comes out at, it's about minus 31. Again, there's no penalty for rounding there because he hasn't given you any guidance on how to round it. Okay, so there's no penalty there, so it's minus 31. So two things then. First of all, obviously we want to put the units in. So like we were talking about on Wednesday, it's these units per those units. We did a lot of kind of calculus type questions on Wednesday, so it's these units per those. What's C measured in? It's milligrams per 100 centimeters cubed. And what's time measured in hours per hour? Now, it's okay to leave it like that. He won't penalise that. I mean, you've got two pers there, if you like. Okay, so what that means both these are below the line. So that's more accurately minus 31 milligrams, okay, per 100 centimeter cubed hours. Right, so it's okay, but either one of those is fine. Okay, or centimeters cubed multiplied by hours if you want to do it that way. And many of you are who do... if you do kind of physics or applied maths, you're probably used to writing them that way instead. You might be writing that as milligrams, 100 centimeters cubed to the power of minus 3, hours to the power of minus 1. Using negative powers is fine, but don't get too bogged down. Once he sees, look, you've got the units for concentration here and the units for time, he won't worry too much about how you tidy those up. You just want to make sure you're familiar with what the units are. Okay, so that's the rate there. Now, and the second thing to point out, it's minus 31. Look at your graph here. So remember, the graph is for the first 5 hours. So the graph looks like that. It goes up here and goes back down. There's the first 2.5 hours. And it repeats that again like that. So there we go. So there's 2.5 hours there. There's the first cycle. and then there's 5 hours there, right? And remember, that's 1.25 there. And again, halfway between 2.5 and 5 is 3.75. So that's 3.75 there. Okay, because remember, it's an hour and a quarter, it's another hour and a quarter, it's another hour and a quarter, it's another hour and a quarter, like that. Right, so that's the graph looks like if I go for the first 5 hours. Now, where's the number 4? Where's 4? 4 is in between these two here. So 4 is this part of the graph here where the graph is going down. That's negative. Okay, I'm happy with that. So it looks like his blood sugar should be dropping at the 4 hour mark. My sketch suggests as much. Okay, so that's your derivative. So as I said, it's really important to watch out for the word rate. Remember how to find that differentiation, and the fact that the positive means that something is increasing, negative means it's decreasing. It's not a bad idea if you've drawn the sketch to check that those two match up. Okay? Happy with that? Now,